All right, fellow scientists, I am going to share exactly what you need to know for the Chapter 22 test. And as you know, the Chapter 22 is all about the Earth. We've started a section on Earth science here, and specifically Chapter 22 discusses the Earth's interior. Okay? So this is Section 1, and I'm just going to quickly go through Section 1 and detail what you need to know for this section, and then the other videos will be for the other sections in this chapter. Okay? Alright, the first section here is all about the Earth's structure. Now, in many ways, we know less about our own Earth than we do about the universe around us, because it's hard to examine the Earth below our feet, but there have been different ways where we can discover some things about the Earth's interior. Anytime we are studying the planet Earth, that is called geology. So you need to know that field of science that is studying Earth is called geology, and the scientists who study geology are called geologists. All right? And that includes the composition and the structure of the Earth. And this chapter is specifically talking about the Earth's interior. And you should know that the Earth undergoes basically two types of forces. They are constructive forces, and those would be things that are building things, building up mountains and other land areas. And then destructive forces. Destructive forces are those that are wearing down the structures on our Earth, so erosion and wind and weather that are wearing things down. All right? And this is going to come up again as we talk about the rock cycle and producing sediment. You should be aware of the name James Hutton. He was basically kind of the father of geology. So modern science, the modern science of geology began with James Hutton, and he was making observations of rocks and the particles that came from older rocks, and basically he is given the credit for determining that the Earth's surface has changed gradually over time. He coined the phrase, the idea of uniformitarianism. So you should need to know this term, which basically says the processes that we are observing today also happened in the past. Okay? So all the processes, the things that we're seeing that are changing our Earth's surface or the interior of the Earth, all of them, even though they're happening slowly, they happened at the same rate and then in the same way in the past. Whatever's operating today also operated in the past. It's from that viewpoint that we come up with the idea that long periods of time have been necessary in order to create the mountains that we see, or the valleys, or the canyons, and the other land structures that we have on our Earth. Okay, let's talk a little bit about the Earth's interior, and we'll approach it by considering a cross-section of our Earth. Kind of like if you were to cut away at something and then look at the inside of that object. Basically, the Earth, you need to know this, and this is a key point here. You've got three main layers of the Earth: the crust, the mantle, and the core. You need to know these. These three different layers are divided. How are they divided? They're based on the materials that make up each layer. And you need to know that. Okay? These different materials then are going to give those layers different densities. There's going to be different types of minerals and rocks and elements that make up those different layers, and it's going to give each of them a specific density or a range of densities. You also should know that temperature and pressure is going to change as you go from layer to layer. And we did an activity, or at least we looked at a question about this, and looked at some diagrams in this. Obviously, as you go deeper into the Earth's interior, the temperature is going to go up, as will the pressure. And so those two measurements change as you go deeper into the Earth's interior. Okay? They both increase with depth. You should definitely know that. All right. Let's look at each of the layers a little bit individually and highlight some of the important points here. The crust. So we live on the crust, and you should know that the crust is the thin layer on the very exterior, the very outside of the Earth. There is the continental crust. That's the land, basically, that we all live on. And then you've got the oceanic crust, which is below the ocean. That's below all of the ocean bodies of water. Oceanic bodies of water, anyways. All right. Now, also you should know that the continental crust is mainly less dense than the oceanic crust. And if you remember, that came up as we talked about places where the continental crust and oceanic crust meet and they are converging, because it was the oceanic crust that would go below the continental crust, because this was more dense and this was less dense. So it was the ocean here, oceanic crust, that would fall or get pushed below the continental crust because of the difference in densities. All right? So continental crust, and this is where you see your land masses, your mountains, and the oceanic crust then is below your oceans. That's basically what is the ocean floor. Okay? The continental crust you should know is a little bit thicker because you've got your mountains, etc. And the oceanic crust is a little bit thinner, but more dense. Okay? But it's more dense. All right. The mantle then is the layer between the crust and the core. The mantle is your thick layer of hot but solid rock. In some cases, that rock is fluid. Remember, we talked about the currents. We talked about those currents in the mantle and how those currents then are going to influence the crust above it and going to form either divergent or convergent. These arrows are showing the currents in the mantle, okay? And then where the crusts come together either at a divergent or a convergent meeting is going to determine how those different plates are going to interact. They're either going to get pushed away from each other and magma is going to come up through that hole and fill that space, or they're going to push against each other and we're going to have either mountains formed or you're going to have one crust or one layer being pushed below another. Okay? As mentioned already, you should know that pressure and temperature increase tremendously the deeper you go into the mantle. Then the mantle, of course, scientists like to divide this even further into the lithosphere, and this is relatively cool, rigid rock, and that's the uppermost part of the mantle. Okay, it might include part of the Earth's crust. That's the lithosphere. Then you've got the asthenosphere. It's a layer of softer, weaker rock that can flow slowly, because this is where we kind of get our currents. We might get some of the currents here. All right, so that's your asthenosphere. And then beneath that is the stronger lower part of the mantle called the mesosphere. And this is a stiffer rock, and it goes all the way down to the upper surface of the Earth's core. It goes down to the Earth's core. So just think of LAM, L-A-M. This is the lithosphere, asthenosphere, and the mesosphere. And the reason why those are divided is because in the mantle, these are all part of the mantle, but in the mantle there's slightly different densities or how solid a different layer is. And so you'll notice that the lithosphere, because it's closest to the crust, is a little more solid. The asthenosphere is a little less solid. You get some flow there. And then the mesosphere is closer to the core, and the rock is a little bit stiffer as you get closer to the core, at least the outer core. but all of these make up the mantle, LAM, and they're divided into those layers because they behave or are slightly different in their composition. Okay? But again, the main parts are your crust, your mantle. In your mantle, you've got your lithosphere, asthenosphere, and your mesosphere, and then your outer core. Now, this is actually your core, I should say. This is the core. You have outer core and your inner core. We'll talk about that now. Okay? All right. Okay, let's talk a little bit more about the core. The core here, it is basically the large metal sphere inside at the center of the Earth. It's at the Earth's center. That core is mostly made of iron, nickel, a little bit of nickel, maybe some lighter elements. The pressure is extremely great. As we mentioned already, the pressure increases as you go further and further down and toward the center. And the temperature is extremely high. Okay? Now, the core is divided into two parts. It's the outer core and the inner core. And simply because there's slightly different changes or slight differences in the temperatures and the substance. So the outer core, high temperatures keep the liquid metal, or the metal liquid. So it's metal that is liquid metal. Okay? This, by the way, because of the Earth's rotation, and you've got this liquid metal in here, that iron that is able to flow, that is where we get our magnetic field produced. You guys know that the Earth has a magnetic field. The inner core is so high under pressure that it is solid. That's the main difference. So your core, you've got the inner core and the outer core, and the reason there's differences made there is because the outer core is mostly liquid and the inner core is solid. Okay? All right, that basically is what you need to know for the Earth's interior.